Alright, so this is going to be a quick video. We're going to be looking at some interview skills, and this time we're going to be looking at things you've looked previously in school, lower down, such as GCSE, but with a different scope. And in this case, we're going to be looking at circle theorems in geometry. So what I'm going to do is draw myself a circle. And in this case, we're going to be proving the angles in a semicircle are 90 degrees. And how we're going to do that is we're going to be looking at the method using vectors. So if I just draw essentially my triangle right now, and let's say this point's going to be my center, doesn't have to be perfect. We're going to call this vector A, we're going to call this vector B, and the vector that goes across the diameter must then be A plus B. I'm not going to draw on the line for now. I'm just going to draw it just above, but yeah, essentially the vector going across the diameter needs to be A plus B. Now, if we want to prove that this angle is 90 degrees, we're going to have to try and say the dot product between A and B equals 0. That will give us if we can get there, we've essentially proven the statement. Now, how we're going to do that is we're going to include the fact that this is a circle. Now, if we don't do that, we're basically working with just a triangle, and this could be any triangle, and we wouldn't have a sort of basis to go and prove the statement. So how we're going to incorporate this circle? Well, one thing we know is that the diameter is twice the radius, and this diameter here, I'm going to split it into a plus b over 2 and a plus b over 2, and I'm going to draw this radius, this part of the radius in as well, and that's going to have the same length of a plus b over 2, and we'll come back to that in a moment. But we can work out this vector here, the vector that goes from, let's call this point big A, and that's going to be O. We're going to call that point C and call this point B. We're going to try and work out the vector OC. Now, if we call OC, let's say X, we're going to call this X. What we can do is just say X plus A plus B over 2 equals A. You can see that from like the triangle I've drawn, the vector triangle I've drawn there, that AO plus OC needs to equal AC. And then all we have to do essentially is just rearrange this equation and we to minus B over 2. And remember including that vector symbol. Now, if we put that all into one fraction, just for conciseness, we'll get this expression. Now, what we're now going to do is use the fact that AO, the length of AO and the length of OC need to be equal, and that means it's a radius. So I'm going to make the statement that X needs to equal A plus B over 2, and just say that this is a radius. And that's a property of the circle. Now I'll just substitute what X is, and I'll get A minus B over 2 equals A plus B over 2. Get rid of the halves, and we're left with this. A minus B, the modulus of A minus B rather, equals the modulus of A plus B. If I square both sides, I can then write this as a dot product expression. So this is going to be A minus B dotted with A minus B equals A plus B dotted with A plus B. And then now if I expand this all out, I should arrive at an expression which should prove the statement, and that's going to be magnitude of A squared minus B dot A minus A dot B plus the magnitude of B squared, and that should equal magnitude of A squared plus B dot A plus A dot B plus magnitude of B squared. Now these are standard Euclidean vectors, so we're going to say that the dot product between x and y should be equal to the dot product of y and x. And then now we just simplify. So this should be magnitude of A squared minus 2A dot B plus magnitude of B squared equals magnitude of a squared plus 2a dot b plus magnitude of b squared. Now, I'll just get rid of my terms here, and then arrive at this expression, 4a dot b equals 0, and we arrive at a dot b equals 0. And so we've proved it. We've proved the circle theorem, and there's a million other ways we can also prove the statement, but we did it one way using vectors.